Students, let's continue with the MAC protocols classification. So far we had seen about the contention based protocols. Now let's see the second part. The second part is the contention based protocols with reservation mechanisms. So the reservation mechanisms can be divided into synchronous protocols and asynchronous protocols. So these are all the synchronous and this will be the asynchronous protocols which are used for the data transmissions, the MAC protocols for ad-hoc wireless networks. So now let's see about contention based protocols with reservation mechanisms. So I want to explain about these contention based protocols with reservation mechanisms in 3 videos. So the synchronous, asynchronous. So the contention based protocols, actually it's a connection occurs during the resources bandwidth reservation phase. Actually it supports the real-time traffic and it reserves a bandwidth a priority, and it has the synchronous protocols and the asynchronous protocols. The contention based protocols with reservation mechanisms may be synchronous or asynchronous. So once the bandwidth is reserved, the nodes gets exclusively access to the reserved bandwidth. So whatever the bandwidth that is reserved for a particular node, that will exclusively access to that reserved bandwidth only. That node has to be accessed with that bandwidth only. That is a reservation mechanism. It will be reserved for that bandwidth. The first protocol, which is a synchronous protocol, is DPRMA. D is the distributed packet reservation multiple access protocol. Distributed packet reservation multiple access protocol. So this channel is divided into fixed and equal sized frames along the time axis. So it will be divided into fixed as well as the equal sizes. So see here the frame structure of a distributed PRMA. So here the frame length, the complete frame is divided into S slots, slot 1, slot 2 up to S slots. Suppose whatever the slot that we wants to be sent, that slot again divided into mini slots. Mini slot 1, mini slot 2 up to M slots. So whatever the slot that is selecting, that wants to be sent, that is a mini slot, is sending the request to send BI and the clear to send BI. So here the request to send BI and the clear to send BI are used for the slot reservations and for overcoming the hidden terminals problems. Why these two we are using in the slots? In each and every slot, whatever the slot, mini slot you are taken, each mini slot is having the request to send BI and the clear to send BI. Those will be used for the slot reservations and for overcoming the hidden terminal problems. So here the PRMA was designed in a wireless LAN within a base station. Okay, so this is about the DPRMA. So here the DPRMA extends the PRMA protocol in a wireless LAN, and the DPRMA, that is the dual distributed packet reservation multiple access protocol, is a TDMA, time division multiple access base schema. So the channel is divided into fixed and equal size frames, so whatever we said now. So in the distributed packet reservation multiple access protocol, just remember this frame structure, and here the frames are divided into the slots. Each slot again divided into mini slots, and each mini slots is holding the request to send and clear to send for the slot reservation and overcoming the hidden terminal problems. Now coming to the next protocol, that is a synchronous protocol in the contention based protocol with reservation mechanism, that is CATA, collision avoidance time allocation protocol. So here the thing we have to avoid the collision. So how we can avoid the collision? It can be based on the time allocation protocol. So that's why we call it as a collision avoidance time allocation protocol. It is based on dynamic topology dependent transmission scheduling. So it supports the broadcasting, unicast and multicast transmission simultaneously. So the collision avoidance is supporting all types of multicastings, the broadcast, unicast and multicast simultaneously. So that's why suppose in these cases whenever the collision is occur, that can be avoided by using the time allocation protocol. So here each frame consists of S slots. So just like a DPRMA, the CAT is having the frame with slots. Each slot is further divided into 5 mini slots. The main difference here between the DPRMA and CATs. DPRMA is divided into so many mini slots. Each mini slot is reserved for slot reservation. So whereas here the slots are divided into only 5 mini slots. Only 5 mini slots. So see here. So those 5 mini slots are CMS1, we call it as, which is used for the slot reservation SR. CMS2 is for request to send. CMS3 is clear to send. CMS4 not to send, and DMS is for data transmission. So totally it divides, each slot is divided into 5 slots. Whereas in the previous DPRMA, each slot is reserved for RTS and clear to send only. Okay, but here each slot is divided into 5 slots. Okay, each slot, that mini slot, in the terms of the mini slot, will be divided into 5 slots. So CMS1 is reserved for slot reservation. CMS2 is for request to send, clear to send, not to send, and the data transmission. Okay. So now let's see how this works. So here each node receives a data during the DMS. So data transmission of current slot transmitting in SR in CMS1. So here every node that transmits data during, so let me just clear view like this, take this paper. So here whatever the node that wants to transmit during the data transmission, the first current slot transmits, the request to send. That is SM2 has to be activated. First it has to send the request to send. So whenever that request to send is sent, then the sender transmits the RTS in SMS2. Then the receiver is clear to send in SMS. So here SMS3 is sending the clear to send. So everything will be done in a single slot. In a single slot, it first for the slot is asking slot reservation. Next it is asking for request to send. In the same slot only we will get the confirmation. If you don't want, you just send the not to send, and that finally the data has to be transmitted. So that here they are explained. So once the reservation was successfully in the next slot, both the sender and receiver do not transmit anything during SMS3 and during SMS4. The sender transmits a no transmission. So here the CATA works well with simple single channel half duplex radios. Okay. So these two are the synchronous, and one more this HRMA. Still 2 more are there. So let's explain the HRMA also, which is a hope reservation multiple access protocol. A multi-channel MAC protocol which is based on the half duplex, very slow frequency hopping spread spectrum. So that's, you call it as FHSS radios. Okay, it's having a very slow FHSS radios. This hop reservation multiple access protocol uses the reservations and handshaking mechanism. So it uses both the reservation, not only the reservation itself, these protocols are the reservation contention based reservation protocols only. Not only it takes the reservation, and it also handshake mechanism to enable a pair of communicating nodes to reserve a frequency hop, thereby guaranteeing collision free data transmission. And it can be viewed as a time slot reservation protocol where each time slot is assigned a separate frequency channel. Okay, so just remember that this HRMA, that is a hope reservation multiple access protocol, which is a synchronous protocol, that is a contention based reservation mechanism. It uses both the reservation and the handshaking mechanism. Here the time slot reservation protocol where each time slot is assigned a separate frequency channel. Thank you.